All right, does anybody remember what the arrows in a food web, what they represent? The flow of the energy, yes, exactly. I got a lot of different things. I got who eats who. Put this up, sir. But it's the flow of the energy. Where's your journal? You already put that on there? All right. And if we look at a food web that actually, starts from the sun and also has your decomposers, that kind of shows that it's just not about who eats who. Because plants don't eat sun, they use the energy from the sun. And decomposers like bacteria, they wouldn't eat a wolf. They have to wait till it dies and then they break it down. So the arrows represent the flow of energy. All right. Got a little bit of notes today. If we were at biomagnification. All right, we're ready. Oh, what's you? No, sure. Yes, sure. All right, so biomagnification occurs when there is an increase in the concentration of harmful chemicals in organisms through a food chain. So like energy decreases, but if you have some kind of harmful chemical, it's actually going to increase as you move up a food web or up a food chain. So you may have your producers, so producers may pick it up when they're growing, and then you may have that first consumer eat it, but as you move up each trophic level, that continues to increase. So that continues to increase as we move up there. If a herbicide is put on grass and the grasshoppers eat the grass, some of the herbicide chemicals are stored and accumulate in certain tissues of that grasshopper's body. And then something's going to eat the grasshopper, and that's going to continue. So at each trophic level, the concentration of the herbicide chemical increases. And may become dangerous or even deadly. So examples are lead and mercury in bodies of water. Over the past few years, there have been a lot of talk about lead, and lead can cause brain damage, especially in children. And it can get in the water, and then the kids drink it, or maybe eat fish or eat food that have that, and then that accumulates and becomes more dangerous as you move up the trophic levels. Units that are used when concentration of chemicals are very small is ppm, which stands for parts per million. And this represents concentrations by mass. So it's not like you really have a whole lot. It's still a very small amount, but sometimes even a very small amount can be very dangerous. So that's what, if we look at these diagrams here, and it's kind of hard to see, but the red dots represent the DDT, which is a type of fertilizer that can be very dangerous. But up here at the top, this is where we're going to see the more serious or the most serious effect. Starts here in the water, and the zooplankton eats that, and then it continues up to the eagle, may be the one that actually has the most effect from that. And because it's really opposite of what you see, because it's really opposite of what you see in a food web or a food chain, you end up with an upside down pyramid because it is increasing as you go up. Our energy pyramid was the other way around because it was decreasing. Our energy decreased as we moved up the trophic levels and moved through the food web, but this is opposite. This is called biomagnification, so it's actually increasing as we move through the trophic levels. Y'all have a section that's filled in? Okay. So we're going to kind of move through that pretty quickly, the section that y'all have that's already filled in, and then we'll talk about symbiotic relationships, which I think y'all probably heard of before. So just understanding ecosystems, a biological population of organisms. Those are all the same species. Remember, if something is the same species, that means it can breed and produce offspring that are fertile. So like a donkey and I think it can make a mule, right? Donkey and a horse can breed and they can make a mule, but then the mule is sterile. It can't have offspring. So that's because they're of different species. Biological communities is made of interacting populations in the same area. So then those are going to be, now we're putting different species together, like in our town, Bay City, and then we end up with a population. Organisms in any kind of ecosystem are going to compete for resources such as food, water, and space. I mean, that's limited. For us, we can go to the grocery store, but for animals or plants that are competing for something, obviously they don't have that outlet. So they'll have limiting factors that are going to affect the ability of the organism to survive. And examples of that would be food, water, predators, temperature, shelter, space, disease. And that's happening here in Matagorda County. We may not really see it like you would see if you know that animals are going extinct, but that is happening here also in Matagorda County. Limiting factors can either be density dependent or density independent. So density dependent factors are going to be, this is supposed to have an R in front of it, got cut off, resources. So that means the higher the population gets, the more dense the population gets, the quicker these are going to be used up. So those would be typical resources that you think of, like food or water, or maybe predators. If population gets more dense, it's going to be easier for the predators to attack that population. Density independent factors do not depend on the size of the population. Those are different types of conditions. It's supposed to be a CO. So things like temperature, the weather, whether we're having a hurricane, whether we're having a heat wave, those things are going to affect the population, but it's not dependent upon how many are in that population. If I'm having a heat wave, it's going to affect a large population the same way that it affects a small population. Or if I'm having a drought, or if there's a drought, it's going to affect a large population the same way that it affects a small population. So that comes back to the carrying capacity. So the carrying capacity of an ecosystem is the maximum number of individuals that an environment can support. I don't know if any of y'all have family or your family deals with like cattle, or probably around here, it would probably mainly be cattle, maybe pigs, something like that. You know, if somebody has cattle and they're trying to make some money off cattle, they can't just put those cows in a pasture, can they? And they can make them shoulder to shoulder, right? Because there is a limited carrying capacity. How much land does each cow have to have? And it may be different. Somebody may take a little bit better care of their land, and they may have really good grass, and they may be able to hold more cattle than somebody that hasn't taken as good a care, and then they may not be able to hold. The carrying capacity would be lower. So carrying capacity is going to be how much, what is the limit or the ability of the resources in that specific area. When we talk about population growth, it can be one of two kinds. It can be exponential or it can be logistic. So exponential growth occurs over a short period of time. So whenever that happens, the population increases real fast to begin with. Just like if you're doing math, you know what an exponential curve looks like, how it goes very quickly, goes up. And the growth curve resembles kind of a J, and we'll see a picture of that in a minute. With logistic growth, it starts off rapid, but then it slows down when it gets to that carrying capacity, and then it kind of levels out. So that growth curve will resemble kind of a stretched out S. And there's pictures of that on the next page. So if we look at that first one, whenever it takes off, you can see here's the number of individuals. So it takes off and it goes very quickly over a short period of time. That's going to be your exponential growth. And this is rapid growth. The other one we said is called logistic growth. So you can see it kind of takes off pretty quick, but then when it gets to that carrying capacity, it kind of stabilizes. Because once it gets to that carrying capacity, it can't continue to increase. It's kind of met its limit right there. So logistic growth is more realistic for most environments. All right, so what we're going to talk about for the rest of the class period, and then we'll look at a little video, is some symbiotic relationships. So I think as we start talking through these, they'll sound kind of familiar with you. So symbiosis is a close relationship between two different organisms. So those organisms are going to live in direct contact with each other. So there's three types: parasitism, mutualism, and commensalism. Y'all heard of those before? Those sound a little familiar? In this relationship, parasitism will start off first. In this relationship, one organism benefits and the other organism is harmed. So who can think of a real typical parasitic relationship? Anybody have any pets? Do they ever get fleas or ticks? Never? That's pretty good. I do. We're going to take pretty good care of her, but that would be an example of a parasite. The tick is feeding on your dog, it's getting a benefit, it's hurting the dog. So the parasite lives in think of a tapeworm or any kind of worm, live in or on the other organisms. And that other organism is called the host. So like in our case, we were talking about the dog would be the host. The parasite usually does not kill the host, because then the parasite would not have any food. So it doesn't want to kill it. It wants to get all the food it can from the host, but it would really not kill it. Now, sometimes, I don't know if y'all ever watched some of those reality shows where they rescue dogs or something like that. Sometimes you will see them brought in where the fleas are so bad it could go to the point of killing them. But in general, they usually don't. The parasite is usually smaller than the host. So examples of those would be fleas on a dog, mistletoe on a tree. Anybody know what mistletoe is? When do you think of mistletoe? Christmas time? Mistletoe, that stuff you're supposed to, if you walk under it, you have to kiss somebody. But that really, if in its real life before, we usually have plastic, but even if you get real mistletoe, but if it was just out in the wild, it's living off a tree and getting its nutrients from a tree. Or roundworms in a cow. All right, the next one is called mutualism. So just kind of like it sounds. They're both being helped. So in this relationship, both organisms benefit. So an example of that would be alga and fungus in lichen. That's L-I, oh, wait a minute till I get there. L-I-C-H-E-N. And you'll see that on trees sometimes, especially during this time of the year. E. coli, capital E with a period, and then C-O-L-I, that's a type of bacteria. And human intestines. We need bacteria in our intestines to help us process the food and also to help us make vitamins. And E. coli is one of those. So we're helping it because it's getting nutrients from us, and then it's helping us. And then a type of fish is called wrasse, W-R-A-S-S-E. Fish in black sea bass. And you'll see this sometimes with fish. A little smaller kind of fish will attach itself onto a larger fish, and it may eat some kind of fungus, or it may eat something that would be detrimental or hurt the larger fish. So it's getting nutrients and it's helping out the fish also. All right, move this up a little bit. And then the next one is called Commensalism. And this one organism benefits. Where am I at? One organism benefits. And the other organism is unaffected. So it's not hurt, it's not helped. So a perfect example of this would be a bird's, excuse me, nest in a tree. The bird's being helped because that nest is up away from predators. The tree's not being hurt or helped. barnacles on whales. So barnacles will attach themselves to whales, and they'll kind of get that, like when a whale eats, it lets out a lot of extra little small food, and then the barnacle will eat that. It's not hurting the whale by being attached to it. And clownfish, which is like a Nemo. And sea anemone. ANEMONE. So those are, they look kind of like plants in the water, but they sting. So the clownfish will hide out to hide from their predator, so it's not hurting the sea anemone, but it's being helped. Sea anemone's not hurt or helped. And then predation is not really a symbiotic relationship, but it is a type of relationship where one organism hunts, kills, so that's going to be a little bit different right there, and eats another organism, which is called the prey. So the predator eats the prey. So of course you can think of an example: wolf and deer, lion and antelope, owl and mouse. There would be a lot more. We can become predators when we go and hunt, right? I don't know if any of y'all are hunters or your family are hunters. We hunt, kill, and then if you eat it. So that's predation. All right, so I have a little video over symbiotic relationships. And we'll look at that.
Writing's not that easy, but Grammarly can help. This sentence is grammatically correct, but it's wordy and hard to read. It undermines the writer's message, and the word choice is bland. Grammarly's cutting-edge technology helps you craft compelling, understandable writing that makes an impact on your reader. Much better. Are you ready to give it a try? Installation is simple and free. Visit Grammarly.com today.
Let me roll out. She said.
Imagine the places we'll go.
Together, expedient.
All right.
It's a dog-eat-dog world, but just sometimes, if you want to get a head out in the wild, it pays to work together. When different types of creatures interact with one another in the interest of survival, it's called a symbiosis, and intentional symbiotic relationships are surprisingly common in nature. Depending on who benefits from the relationship, partnerships can either be mutualistic, commensalistic, or parasitic. Mutualism is when both creatures benefit from being around each other, like these remarkable underwater fish spas. Upwelling, nutrient-rich waters draw huge numbers and varieties of fish to seamounts and reefs, but not all of them are good for the food. Hammerhead sharks, turtles, and even manta rays make their way to these specific locations for none other than a premium cleaning service. These big fellas drift calmly around the reef, allowing smaller fish like wrasse, surgeonfish, and angelfish to pick off parasites in algae, leaving them feeling fresh. The big fish get a luxury exfoliation, and the small fish get a tasty meal, so everyone's a winner. Of course, there's always that one friend that asks for just a little too much, and in this case, it's the manta ray, who times its visit to coincide with a sturgeonfish's spawning season, so it gets a free meal of fish eggs along with its wax and polish, which, frankly, just seems a little bit rude. On the other hand, if only one creature in a partnership benefits while the other is relatively unaffected, it's called commensalism. Aphids are tiny insects that feed on plant sap. When they bite into a stem, the sugary liquid surges out under high pressure, in through their mouths and straight up their direct. These back-end secretions are called honeydew, and they're a choice delicacy for their symbiotic companions. Because while the aphids are minding their own aphidy business, ants are actively arming them and creaming off the delicious honeydew. Stroking their antennas over the aphids' bodies encourages a droplet of honeydew to form, which they can then drink. And the ants will even move their aphid herds around to more productive areas of the plant when supplies start to dry up. So, delicious drink for the ant, business as usual for the aphid. Only it's not quite as innocuous as it seems. In order to keep their aphid pets at home, the ants resort to more aggressive tactics that are definitely not business as usual. Ripping off the aphids' wings and even drugging them with chemicals on their feet to make them stay in one place. And since we've strayed into such sinister territory, let's talk about parasitism, the most toxic of symbiotic relationships. In these partnerships, one creature benefits at the expense of another. And while the survival of the parasite depends on the survival of the host, the freeloaders can often cause illness and eventually death. There are loads of parasites, from fleas to tapeworms and mistletoe, but by far the creepiest out there is the cordyceps fungus. Cordyceps spores infect insects like this bullet ant, and in true zombie fashion take over its brain, making it climb high above the forest floor and clamp onto a twig with its mouth parts. Locked in its rictus grip, the fungus has the perfect anchor and nutrients from the insect's body to grow its own fruiting body. Once this matures, more spores will burst from its tip, and with the wide dispersal that the high vantage point affords, can infect and decimate entire colonies. And what's even more terrifying is that there are thousands of varieties of cordyceps fungus, each capable of brainwashing a different insect before consuming it from the inside. So there you have it. Amazing symbiotic relationships that might not be so amazing for everyone involved. True, you can get ahead by working together, but as with so many things in life, it helps to keep an eye out for yourself as well, or you could end up nothing more than a drug aphid. If you enjoyed this video, be sure to give us a like, and if you're new around here, click subscribe and hit the bell icon to get our Earth Unplugged videos straight to your inbox. We'll see you next time.
You can't predict when you'll use the most electricity.
All right, so we are going to stop right there for today. There's nothing, you don't have any worksheet to do. Tomorrow we will carry on with symbiosis and do a little worksheet, then a little activity on that. All righty?
Yes, well.
All right, Jalen.